Welcome back to The Explainer. Today, we're taking a highly focused look at a seriously demanding discipline, strategic oversight in aerospace and defense program management. Look, if you've ever stared up at a fighter jet, a machine with over 300,000 individual parts, or watched a heavy lift rocket launch and thought, how does this whole shebang come together without, a catastrophic failure? Well, you're in exactly the right place. We're going to demystify this hyper-complex world today. We're going to see how structured oversight is basically the ultimate glue, bringing order to what could easily just be absolute chaos. Okay, let's dive right into this. We've got a clear roadmap today. Number 1, the high-stakes concept. 2, innovation and production oversight. Then 3, regulatory and security alignment. 4th, we'll get into managing the full life cycle. And finally, number 5, delivering mission-critical value. Section 1, the high-stakes concept. Before we get into the nuts and bolts of program management, we really have to establish the sheer gravity here. What are the stakes of a single point of failure in global aviation or defense cybersecurity? I want you to literally imagine that for a second. We're talking about a single line of faulty code in a defense satellite network, or a microscopic fracture deep inside a commercial jet engine. In a normal business, a failure means a delayed launch or maybe a bad quarter. But in aerospace and defense, a single point of failure can mean compromised national security, billions of dollars vaporized in orbit, or far worse. The margin for error isn't small, it's effectively zero. And that is exactly why this rigorous oversight is absolutely non-negotiable. Which brings us to our core definition. Program management in A&D is the structured oversight needed to align research, production, and deployment projects with strategic objectives. Think of this as the ultimate systems integrator. These are the folks holding the master blueprint, making sure the brilliant, highly experimental research in the lab translates flawlessly onto the heavy manufacturing floor and eventually out into the field. It's the critical bridge resolving the tension between visionary engineering and, practical reality. Now, what's really interesting about this is the sheer scale of coordination. It is massive. We're dealing with a triad of core stakeholders: governments, contractors, and international partners. Program management forces these massive, completely disparate groups to actually coordinate safely. You've got strict national regulations clashing with corporate profit incentives and ridiculously complex global supply chains. But to make this work, they all have to be perfectly synchronized. Moving right along to Section 2, innovation and production oversight. Let's see how this actually works in the real world. First up, research and innovation. We're looking at advanced engineering projects, space exploration initiatives, and defense technology development. This is the bleeding edge of science. Whether it's engineering hypersonic materials or writing next-gen space software, it's inherently experimental. It's full of unknowns. But program managers step in and bring vital order to that cutting-edge chaos. They ensure even the wildest, most far-reaching concepts stay completely tethered to the main strategic objectives. But having a great research phase definitely isn't the finish line. Once that's done, we hit production oversight. This is all about enforcing incredibly strict quality and safety standards while physically manufacturing the aircraft, spacecraft, and defense systems. Once you're in production, oversight acts as this uncompromising gatekeeper. Every single one of those hundreds of thousands of components has to be perfect, because like we said, there are literally no do-overs in low Earth orbit. All right, Section 3, regulatory and security alignment. Let's zoom out and look at the macro-level challenges. So this perfectly illustrates the dual burden these programs carry. On one side, you have regulatory compliance, navigating aviation laws, defense regulations, and complex international treaties. It's the legal foundation. But on the other side, you're constantly balancing that against global security programs. This is the active, operational stuff: defense readiness, real-time cybersecurity, multinational collaboration. A successful program has to perfectly align both, meeting all the legal constraints without ever dropping the ball on active security imperatives. It's a massive balancing act. Next up, Section 4, managing the full life cycle. It's a huge misconception that management stops when a product ships. In this industry, it is a true cradle-to-grave commitment. Let's move to how this builds across the life of a complex system. It's really 3 distinct steps: maintenance, upgrades, and decommissioning. You don't just build a defense system and walk away, right? Some military aircraft, like the B-52 bomber, fly for over 50 years. That takes intense, ongoing maintenance. Then you have to coordinate upgrades to stay ahead of modern threats. And finally, decommissioning. Actually, when you're dealing with classified defense tech or hazardous spacecraft materials, decommissioning is a massive, highly sensitive project all on its own. Which brings us to our final part, Section 5, delivering mission-critical value. Let's talk about the actual measurable outcomes of all this intense organization. So, what happens without structured oversight in aerospace and defense? I mean, really, if you take away this central coordinating force, what are you left with? You've got brilliant engineers working in total isolation, international partners missing vital regulatory steps, disjointed production schedules. Basically, you get fragmentation. And in this industry, fragmentation is a guaranteed recipe for disaster.
So the crucial point here is the difference between fragmented initiatives and strategically aligned initiatives. Program management ensures that all those complex pieces we just talked about, the engineering, the compliance, the cybersecurity, are never siloed. They are strategically aligned. Taking things from dangerous fragmentation to seamless alignment is the absolute core value proposition of this entire discipline.
And what does that alignment actually yield? 3 massive, measurable improvements: enhanced safety, unwavering reliability, and sustained global competitiveness. When your research, production, compliance, and international partners are totally in sync, your systems don't just work better. They actively allow organizations and entire nations to stay highly competitive and secure globally. It's a real game changer. Deliver mission-critical outcomes with precision and accountability. Just let that sink in for a moment. Precision and accountability are the ultimate goals here. When lives, multi-billion-dollar investments, and global security are quite literally on the line, you have to deliver exactly what was promised. And you have to do it with a completely clear, traceable trail of accountability through every single phase of development, deployment, and eventual retirement. So as we wrap up this explainer, I want to leave you with one final thought to ponder. How will these structures shape the future of global security and space exploration? Because as our ambitions accelerate, as we push deeper into space and face completely new global security threats, the rigorous oversight holding these massive projects together is only going to become more critical. Thank you so much for bringing your focus to today's explainer. Keep analyzing, keep learning, and we'll see you next time.